Greetings. Let us continue with the part of estimation of ultimate load bearing capacity of single vertical pile. Various methods are employed to do so. They are first, by the use of static bearing capacity coefficient, by the use of SPT and CPT values, by the use of field load test, and by dynamic methods. In dynamic methods, some empirical formulas has been suggested for the determination of bearing capacity. The determination of ultimate point bearing capacity QB of a deep foundation on the basis of theory is very complex. Once there are many factors, since there are many factors which cannot be accounted for this theory. For example, the assumption such as soil is homogeneous and isotropic, which is normally not the case in case of deep foundation. The second parameter here involved is the friction, which depends upon the material and the surface characteristic and the method of installation. That's why assumption of QB and estimating the value of the QB is become a complex problem. For this, there are number of theories suggested by the scientists. We know well about the Terazaghi equations, which has been suggested for finding out bearing capacity of shallower foundation, which can be extended for a certain depth. But when the L by D ratio is more than 5, then this type of assumption is not doesn't remain valid. That comes a limitation. Similar, this limitation was found towards the assumption made by the mayor of later in Basic in 1967 has suggested a solution that when the L by D ratio is greater than 5, then there is the domination of the punching shear failure. There will be no more existence of general shear failure and local shear failure. With these assumptions, let us move further towards the estimation of load bearing capacity. As we know that the total load bearing capacity, ultimate load bearing capacity of single pile QU is QU. Now I am going to talk about the net ultimate bearing capacity of the pile. So QU bar will be equals to QU, the bearing load bearing capacity of your pile, plus WP, where the term WP here stands for your weight of the pile. This weight of the pile has to be taken in account for estimating the ultimate load failure load which the pile can carry. The total ultimate failure load is equals to QB plus QF plus WP, where QU is being expanded towards its uh, component parts like QB the load carrying capacity under bearing, and QF is the load bearing capacity under friction. So our shaft resistance, we can say base resistance and shaft resistance, it will be very comfortable for us to speak about it. Now let us go towards the estimation of QB. QB is equals to, we know this component part which we use for estimation of a unit uh, bearing capacity of soil. So it is given by the equation C NC plus Q naught dash NQ plus 1 half of gamma into D into N gamma. These are the coefficients which were suggested by Terazaghi. Multiply this by area of bearing, we will get the total load carrying capacity in terms of a base resistance, where Q naught dash is the effective overburden pressure at the base level, this one Q naught dash, and the C is the cohesion of the soil, gamma is the unit weight of the soil, NC, NQ and N gamma are the bearing capacity factors which can be found out with reference to the angle of friction given to us and the type of soil given to us. Now, if we'll extend this theory towards the cohesionless soil, we have two types of soils, generally two categories of soils, cohesionless soil and cohesive soils. For cohesionless soil, the shear strength is negligible. That's why we can say C is equals to 0. And the term half of gamma into D into N gamma becomes insignificant with the term insignificant in case of a deep foundation, as Vesic has suggested. As the length to depth ratio of the pile increase, the deeper the foundation, the component n 1 half of gamma in D into N gamma, this force will become negligible. That's why the two terms from this equation get negligible. Then the QB value is estimated as a Q naught dash into NQ. What is the Q naught dash here? Effective of your it is nothing but a effective overburden pressure. Let us continue. Let us say that uh, a pile is there of length L and carries a load along its depth. then the effective overburden pressure at a certain at the base level will be equals to gamma into L. What we have to do in case of shallow foundation, we used to put here gamma into D, which was the foundation level for pressure, effective pressure at foundation level. So here the effective pressure will be given as Q dash equals to gamma into L. Now with this we can conclude that QU bar, that is the total ultimate load carrying capacity of your single pile, is equals to QB plus QF plus WP, where QU bar is equals to Q naught dash NQ into AB plus QF plus WP, weight of the pile. The net ultimate load in excess of the overburden pressure load is equals to, we can say, Q bar NU, net ultimate load carrying capacity at failure, is equals to QB plus QF plus WP minus Q naught AB. Now Q bar NU is equals to Q dash Q naught dash NQ AB plus QF plus WP minus Q naught AB. This Q naught AB is nothing but excessive overburden pressure, which we are going to subtract so as to get the ultimate load bearing capacity. Now let's talk about the practical significance of this. For most of the case, the WP is supposed to be roughly equals to be balanced by the net overburden pressure, and that's why this total component is considered to be having negligible effect. So this is due to the tapering of the ends or bearing ends, or sometimes we can have the profile, a general profile. We consider that they are going to balance each other. That's why these components are generally neglected, and that's why the equation reduces to QU bar is equals to Q naught dash NQ into AB plus QF. Now here we are able to know about the value of what the bearing strength we have. Now we'll talk about the frictional, or we can shaft resistance. To know about the shaft resistance, let's go back to the basic principle of friction. In case of basic principle of friction, we can say that there is a relation between the frictional force attracted by body and the normal thrust which is going to act on a body. So here the frictional resistance F is equals to it bears a certain relation with reference to the angle at which the friction resistance is going to act. Let's say dou is the angle there, then we can get coefficient of friction is equals to tan times of the dou. We have the dynamic equilibrium equation equals to F is equals to mu times of capital N. Capital N is nothing but normal, which is in equivalent to the what we say the vertical force which is going to act on this particular body. So if vertical force is here Q naught dash, so it will become K times of Q naught dash. K is the constant for proportionality. If I want to take a cumulative effect of mu into K, I can write this as a Ks bar. Now we say that is Q naught dash. Here it is going to appear along the length, and along the length we can't say the overburden pressure will have a constant value, it will be average value. That's why we'll consider a Q naught dash bar multiplied by tan of theta. That's why the force which is taken by this uh, particular pile under shaft resistance is equals to Ks bar Q naught dash bar into tan theta, tan dou. So we'll substitute this equation. If I want to put this in terms of resistance, the stress, this is not for force, we can say stress. This component is for the stress. Stress multiplied by the area as. As is nothing but the surface area of embedded length, the length which is in contact with the your soil. That length, that surface and surface perimetric length, I will going to find out. It will be as will be here pi into d into L. For instance, if I say d is the diameter and L is the length, then the surface area can be worked out as a pi the circumference multiplied by the total length, pi into d into L. Okay, now I will substitute this. The final equation of ultimate load at failure is equals to Q naught dash NQ AB plus AS is equals to Q naught dash bar into KS bar into tan of dou, where AS bar is the surface area of embedded length of the pipe, Q naught dash is the average effective overburden pressure over the embedded depth of the pipe, and Ks bar is the average lateral earth pressure coefficient, and dou is the angle of wall friction. Now let's talk about the part related to cohesive soil. For cohesive soil, such as saturated clays normally consideration, we have for phi equals to 0, nq comes work out to be 1 and n gamma come out to be 0. The ultimate load, ultimate base resistance is given as QB is equals to C into NC plus Q naught into NQ. NQ value is 1. That's why we can write Q naught dash multiplied by area of the bearing part. The net ultimate load in excess of the overburden pressure load is estimated as QU bar, means its ultimate failure load is equals to QB plus QF plus WP weight of the pile minus Q naught AB. Now, in case of your overburden pressure, if I consider on the other side with the statics, I can get a relation CNC plus AS alpha times of CU bar. What is this CU bar? In case of your clay, we are going to consider the overburden pressure due to this shear strength will be converted into undrained shear strength. So here QU is the average undrained shear strength of the clay along the shaft, and alpha depends upon the adhesion coefficient. Adhesion coefficient depends upon the nature of the soil. The more the medium, the loose or dense clay is there, there is a, accordingly there will be light dense, it will have more adhesion compared to the coarser dense, more dense. Likewise the coefficient that will depend upon the adhesion factor, that will decide the adhesion factor whether it to be higher or lower on the side. Now this is going to happen along the area of the shaft, area of the surface which is in contact with the soil. That's why this area will be considered as a surface area, so which is equals to pi into d into L. Now C and C. Now for this C we are going to replace it by undrained shear strength, whereas NC we will take help of Skimpton's assumption. Skimpton says that for a L by D ratio more than 5, the NC value must to equals to be 9. So the formula becomes here 9 C plus AS alpha CU bar. Okay, so NC is the bearing capacity factor, and I will replace this factor by taking assumption which was given by Skimpton's. So let us discuss about that also. The value of bearing capacity factor NC that is generally accepted is 9, which the value proposed by Skimpton in 1951 for circular foundation. Means if it is a circular pile for a L by B ratio is greater than 4. The base capacity of the pile in clay soil may be expressed as, now if he is going to consider only the component related to shear strength. So here 9 multiplied by C is nothing but undrained strength, multiplied by AB is nothing but bearing area of your pile. The value of CB may be obtained either from the laboratory test on disturbed sample or from the relation between CU and the field penetration test. So here we can have SPT number corrections and SPT number relation with reference to calculation of CU undrained strain. Now let us go towards the part of a numerical estimation. Let us start with the numerical statement here. The numerical says that a concrete pile of 40 centimeter diameter was driven into a sand of loose to medium density to a depth of 15 meter. The following properties are known. Average unit weight of the soil along the length of the pile is 18 kilonewton per meter cube. Average phi is equals to 30 degree. Average Ks bar is equals to 1. Dou equals to 0.75 and Q is equals to 16.5. Calculate A. Ultimate load carrying capacity of pile and B. Allowable load with factor of safety of 2.5. Now let us try to first classify which type of soil is addressed here. He says 40 centimeter diameter pile is driven in a sand, means it is a cohesionless soil, sand of loose to medium density to a depth of 15. Length of the pile is given as 15 meter. The other parameter he says sand of loose to medium, that's why average unit strength he has given, average phi value he has given, average Ks value he has given. Now we are supposed to find out what is the ultimate load bearing capacity of the pile and what is the allowable load with factor of safety equals of 2.5. Let us continue this numerical in next discussion, as the time constraint is there. We will not be able to completely justify solution of this in this city. That's why we will come once again join. Till then, stay